Hi there. This is a video about piecewise functions. And when we talk about piecewise functions, we have to, I use the word piece when we talk about this. And what I usually say is that these are parts of functions creating one function, okay? And so one of the easiest ways that I can explain what a piecewise function is by using Desmos. So let's jump into Desmos and let's take a look at what that looks like. Okay, so once I'm in Desmos, I just want to type in this function 1/2 x, okay? And I get this whole function for 1/2 x, and at this point, what I want to do is restrict its domain, and I'm going to say that I'm going to use 1/2 x when x is less than 0. And what that does is that's going to cut that graph off when x is equal to 0, okay? I want to type in another function. I'm going to type in x plus 3, so I get this entire function here where my domain is all real numbers. And then I restrict it, and I say that x is greater than or equal to 0. And then all of a sudden, I'm here, all right, and this graph exists. It's split there and there. Now notice that at this point here was undefined at 0, and there's a hole there, and then the other graph here has a point at 0. All right. So one of the things I want to say is that when you're in here, right here, you have a hole, and that's because of your domain restriction saying that x is just less than 0, all right? When x is equal to 0, you have a point here at 3, all right? And that's because that x is greater than or equal to 0 there. All right, so it's easiest to show this using Desmos because it's easy to do the domain restrictions. But let's actually go through how I would graph this piecewise function. Okay, so this is how I would write this piecewise function. So my whole function here is f of x, and it's equal to two different functions for two different domains, okay? And so when I look at this graph here, these are both linear equations, so this one isn't too bad. But these are, 1/2 x, and this exists when x is less than 0, all right? So if I just draw a graph here, all right, and I've got my x-axis, my y-axis. Let's create some points on our x-axis and y-axis. And this will at least kind of give us, something to work with here. And what I want to look at is this first equation here, all right, this 1/2 x. So when you've got y, I just want to think of this equation y equals 1/2 x, okay? From here I know that my slope is 1/2, my y-intercept is 0. And so what I want to, realize is that this function exists when x is less than 0, okay? So what I want to do is figure out, well, at what point on the graph should I start this, okay? So what I do is I look at this graph and I say, all right, if I'm just thinking about this first equation, what's f of 0 if I plug in 0 into this equation? All right, and that's simply just going to be 1/2 times 0, which gives us 0. So f of 0 is equal to 0. Now, because this graph, or my domain is strictly just less than 0, I know that the point 0, 0 is going to have a hole. All right, so I go to 0, 0, and I put a hole at 0, 0. And I have a slope of 1/2. All right, and so what this, not only do I have that point, but I also have to know that the values, that this graph is going to go to the left, because we're dealing with x is less than 0, and that's going to be to the left side of 0. All right, this graph is going to exist to the left because of that. All right, and so I want to then have a positive slope of 1/2, so I'm going to go down 1 to the left 2, down 1 to the left 2, and so I draw a graph going in this direction, okay? So that's the idea on that. That's how I graph that. All right, that's how I get that piece. All right, hence the name piecewise. So now let's take a look at x plus 3. Okay, when I look at the equation y equals x plus 3, what I know is that I have a slope of 1 and a y-intercept of 3. Okay. So in order to figure out, well, okay, where does this start at? I got to use this point here. I got to plug in 0 into this function. All right, so when I plug in 0 into that function, if I do f of x, or I'm sorry, f of 0, I'm going to get 0 plus 3. And so on this function, when I plug in 0, 0 plus 3 is just 3. So that means I have the point 0, 3 on the graph. All right. And I'm going to put a solid dot because x is greater than or equal to 0 at that point. All right, so I'm going to put a dot at 3. So up 1, 2, 3 on my y-axis. All right, and I have a dot like that. And so, you know, the other thing we got to think about is this graph is going to go to the right because we are strictly greater than or equal to 0. And so we also have a slope of 1. So I'm going to come in here and go up 1 over 1. Up 1 over 1, and draw my line going like that. All right, and so that's how I graph those kinds of functions. All right, it comes down to looking at each function, you know, and what I did on Desmos is I graphed the whole thing and then I cut it off at 0. All right, I just put that domain in. You know, on the other one, I graphed the whole thing, made x greater than or equal to 0, and it cut it off here. The question is like, you know, where do you put these points, right? The Desmos does that automatically. What you have to do, again, is plug in this number into your function to get a point. Determine whether you're going to have a whole or a filled in dot, and then, you know, either graph to the left or graph to the right and plot some other points. So that's the idea. Now, this is a function. It follows all of the same things as a function. You know, for every input there's exactly one output. You know, if x is less than 0, like, you know, if I were to say here, let's find f of -1, okay, because -1 is less than 0, I want to use the top function. All right, and so I would plug that in, and let's not do -1, let's do -2. Actually, -1 is fine. And so that's, you know, 1/2 times -1, which gives us -1/2. And that point is going to exist there, okay? If I wanted to, you know, plug it, you know, see what the value is at, say, 2, all right, at x equals 2, if I wanted to find f of 2, I got to think about, you know, the fact that 2 is greater than or equal to 0. It fits in that domain, so I'm going to use this bottom function and plug 2 into that. So I've got 2 plus 3, which then gives us 5. All right, so the point on the graph is the point 2, 5 here. All right, and that's the idea of piecewise functions. You know, parts of functions, you know, put into one is how I explain that. So hopefully that makes sense. Please reach out if you have any more questions. We'll talk to you guys soon. Thanks. Bye.